Hi, everybody. This is going to be for KK.14, which is in the statistics section of IXL for Algebra 1. We're going to be interpreting regression lines. So they're going to give us an equation that was derived from some data set, and they want us to interpret what that M possibly and the B represent. It says Amanda recorded the number of instruments in each drummer set and each drummer's typical solo length. So what she's suggesting is that there is a relationship between how many drums they have in their set versus how long their typical solo lasts, because they need more, clearly they probably need more drums to have their solo last longer. If a drummer has one additional instrument in the set, the typical drum solo would be how many minutes longer. All right, so what we want to do is we want to look at the slope. And remember that the slope is the change in y over the change in x. And the typical solo length is our y value. So this is 0.092, and this is in minutes. And this is over 1 because it is really a decimal, but even if we write it as just as a decimal, we can put it over 1 as a so that we have one instrument. So that for each additional instrument, we expect that the drum solo will last 0.09 or about 10% longer, 9.2% exactly, longer than if it was didn't have that instrument. So we're supposed to put in the entire decimal. So it's 0.092. And one of the things about this particular section, I think they count it wrong if you don't put the 0 in front. So there we go. All right, I'm going to try to make it a little bit easier to follow. This time we have last Saturday she recorded temperature in Celsius. So this is temperature in degrees is X, and the time it took for the clothes to dry. So clearly, if the temperature goes up, the clothes should take less drying time, which is why this is a negative slope. So the negative 0.376 is the drying time in hours. So this is in hours, and it's always over 1 degree Celsius. So for each degree Celsius, the temperature goes up, we expect that it's going to be about a third of an hour, or about 20, a little over that, maybe 22 to 23 minutes longer. You could multiply this decimal by 60 minutes and you'd get minutes instead of hours. So this is, it would dry 0.376. Oh, I forgot. We have to put in the 0. Now, the reason why I'm not going to put the negative on it is because it's talking about that it's going to dry faster. And in this case, that means that it's going to take less time. So this is already indicating that it's less. So I don't want to put the double negative in. That's why I'm putting a positive instead of a negative. All right, now in this one, it says that the recorded dose in milligrams is X, and the rise in blood sugar in milligrams per deciliter is Y. So this time, if the dosage increases 1 millimeter, again, 1 milligram, sorry, we're looking at slope again, and it's negative 0.015. And the whole point to taking the medicine is that it makes the blood sugar go down. And they give you the measurement in milligrams per deciliter. And this is the blood sugar level. This is the level, because that's the Y value. Remember, this is always the change in Y over the change in X. And the change in X is going to be 1 milligram of the medication. So this is the change that we expect to happen with 1 milligram. And because it says less, it already includes the negative. So there it is, darn it, I keep forgetting to put in the 0, 0.015. So apparently it has a 1.5% effect for each milligram of of drug that you take. All right, well, let's see. Now this time, these are 30-second advertisements, X, and the number of customers who visit her store. So the slope, the 23.771, are the number of customers, and the X, one for each ad. So we expect that she's going to see about 24 more customers for each ad that she purchases. With a base of 98 people that come in, probably visited, it says, the number of visits per week. So that's not a very good number. 98 per week if she doesn't do any ads at all, because when I put the 0 in for X, this is the y-intercept, which is about 98 customers. So if she doesn't buy any ads, we expect 98. We expect an additional 23.771, or about 24 customers. In this particular case, you really wouldn't use the full decimal out in there. I would just probably round it to 24, because it's certainly an estimate, but there it is. I know you probably could just guess and stick the number in, but I want you to really think about what it means. Okay, recorded high temperature in Celsius X, and again, we're looking at the slope again. The number of bottles sold Y each day. So bottled water sells better on hot days. And that makes sense. That's why that's a positive slope. If we were talking about as the temperature goes down, and we would expect fewer bottles. So it works out. 1.279 is the number of bottles sold. And this would be additional bottles sold for each 1 degree of temperature Celsius. So for each 1 degree of temperature, we expect to sell 1.279 bottles more of water. Okay, now this one is a different situation than the others. Oh no, it's the same, because the years are in X and the diameter of the trees in meters. Now we need to be careful and make sure that they haven't changed it up on us and said millimeters or something else where we have to change the decimal. But in this case, it's saying that the least squares regression line says 0.057. And remember, it's change in Y. This is the diameter in meters. So this is additional meters of diameter for years, for each year that goes by of growth. And this one says it would be 0.057. In this particular case, the decimal is important, because you're looking at probably a whole lot of trees in a big area. And what you want to do is you want to predict when can you harvest the trees, when do you have to replant them. Forestry involves a lot of linear regression and other kinds of regression as well. You wouldn't have thought so. All right. Now, how many minutes had each student spent on the exercise X? So the X is minutes of exercise, and how many spent on the exercise? Okay, demonstrate the importance of proofreading. So in other words, how long each student spends on proofreading exercise will affect the number of errors that they miss. And what we expect is that the longer they spend practicing, the fewer errors they're going to miss. So this is going to reduce the number of errors they make or that they miss. It's kind of a double negative here too. So anyway, for each additional minute the student spends proofreading, predicts that they will miss how many fewer errors. And again, that makes it a triple negative. So it's 1.179. We expect them to make that many fewer, or miss that many fewer errors. Nothing like including lots of negatives in there, 1.179. And you probably would have guessed, I mean, based on what the other problems say. But again, we don't want to just stick the numbers in and not think about them. All right, let's see. Here's the regression line. That's our model. That's called our mathematical model. And it says, figure out how long it takes to get through a supermarket checkout line. So I'm assuming the Y is how many minutes it took to get to the front of the line. So that's the length of time you spend in the line is Y, and the people ahead are X. So for each additional person, so again, we've got 2.024. These are minutes going by until you get to the front of the line, and this is for each additional. And the reason it's positive is for each additional person, we expect it to take longer. And this is people in line ahead of you. So an extra 2.024. And I know what you're going to do. You're just going to stick the number in until it doesn't work anymore, and then you'll try something else. But I'm hoping that you'll actually think about the problems and try and interpret what these are meaning. Let's take a look at the next one. Round your answer to the nearest integer. Now, Porter accidentally left food in his backyard one night and noticed a cat eating it the next morning. Porter likes helping out neighborhood cats, and he wonders if putting out more food will result in more cats coming to the backyard. I suspect that it will. Over the next few nights, Porter leaves out different amounts of food in grams and notes the number of cats the following morning. Quite an interesting experiment. Okay, so grams isn't a very large number. A kilogram is about 2 pounds. So a gram is a very small amount. But when he increases it, he does get an increase in cats because it says that he gets 0.004 more cats based on the amount of food that he leaves out. Apparently he has to leave out quite a bit because the first cat probably scarfs it all down pretty quickly. So if Porter leaves out 851 grams of food at night, so about 1.5 pounds of food, how many cats will this line predict? Now, this is a totally different problem than the others. So we're going to substitute the 851 in for the X. So we're going to have 0.004 times the 851 grams plus the 0.433. And we're going to evaluate that function real quick here. 0.004 times 851 plus 0.433, and we get approximately 3.837 cats. Now, hopefully you don't find 0.8 cat in the morning because that would indicate a little problem. You can imagine what happened there. Anyway, we're going to round this up to about 4 cats. So if he leaves out about 1.5 pounds of food, he expects to see 4 cats in the morning. I don't think that's an experiment I want to do. All right, we're getting there. Now this one, grape growers in France think that they will have a massive crop, and they want to know how this will influence demand for grape juice. They compare how many grapes were produced in millions of metric tons. That is a lot of grapes. And the amount of French grape juice that was sold in previous years. I suspect that grape juice is wine, but okay. The least squares regression line for this data set is right here. As we expect the demand to go up very small amount if they produce more grapes. So it does look like it has a positive effect. How many billions of liters does this line predict will be sold when 3 million metric tons of grapes are produced? So the 3 is million metric tons. So we're going to substitute the 3 in and see if it has an effect. So 3 times, so I'm taking the 3 and substituting it, 0.031 times the 3 is probably not going to have a lot of effect, is it? Take a look. Times 0.031, it only adds 9/100ths. So when we add the 5.204, it is round your answer to the nearest thousandth. So it is going to have some effect. And we are talking about billions of liters. So 297. and that is to the nearest thousandth when we added it up. So we do expect it to have a small effect, but not a lot. There it is. All right. This is a political ad. Clearly, they want to promote his candidate. Hopefully, it has a positive effect, and it seems to. The ad was aired in at different times depending on the region. To determine how many times to air the ad next week, the campaign manager looks at the impact, which makes sense. That's something that you want to do, is do some analysis on whether the ad helped or not, so that you maximize your return on investing in the ads. What approval rating does this line predict in a region where the ad runs 10 times? Well, I can substitute the 10 in without even using the calculator. 756 times the 10 ads plus 11.537. And we want to round it to the nearest thousandth. So we want to take a look at the approval rating increase. So his approval rating without any ads would be 11.537. That's what we would expect. Not a very good approval rating. But if he runs 10 ads, then we would expect it to be the 7.56 plus the 11.537. And it goes up to 19.097, which is significantly better than the 11. All right, so 19.097. Let's go ahead and just keep going here. That one wasn't as interesting as I would have liked. Samir isn't getting enough sleep and suspect it's due to playing too many video games before bed. To find out, he decides to track how much time he spends gaming. Over the next several days, he's getting hours of sleep, and the number and how many hours he spent playing video games. Here's his least squares regression line. So this is really backwards. It really should have been this should have been his X value. The hours he spends playing video games is affecting how much he sleeps rather than the other way around. In this situation, the way that they wrote it, the sleep that he's getting is affecting how much time he can spend playing video games. And it's having a negative effect on his video game playing. Probably not the way they meant for this to work out. Anyway, how many hours does this line predict Samir would sleep if he played video games for 3.43 hours before bed? I think what they wanted to do is to test to see if you understood what was really happening. So the Y is the number of hours of video game playing, 3.43. And this is negative 1.338x plus 9.955. This is where inverse operations and inverse functions comes in, because the inverse function does the opposite. It predicts, if you put in video games, how many hours of sleep will you get? The equation that they gave us was hours of how many video games you will get if you get a certain number of hours of sleep. Anyway, what we have to do is we're going to have to solve this. So we're going to subtract the 9.955 from both sides in order to solve it. So I'm solving 9.955. And I'm going to go ahead. We've got 3.43 minus 9.955. And we're going to divide by negative 1.338. And so I have negative 1.338x is equal to, let me, sorry, I forgot to write it down. I think this was negative 6.525. I want you to be able to follow along. Then I'm dividing by negative 1.338 to get my x value. And my x value is divided by negative 1.338. and it's only going to be 4 and we went around to the nearest integer, 876. This means that if he spends 3.5 hours playing video games, we would expect that he's only going to get about 5 hours of sleep. Okay. For a project in his political science class, Luttrell researched approval ratings for various mayors in his hometown. He's looking at approval rating just after inauguration and just before leaving office for each mayor. And it looks like there is a relationship there. The final approval rating, does this line predict for a mayor whose initial approval rating was 70%? So Y is the final approval rating. And if we have the initial approval rating, which is the X, we can substitute it for X. So I'm just going to put it in for X. I'll write it out for you, 1.023. The initial approval rating was 70% minus the 29.285. Be careful. Notice that he's using the approval ratings. It doesn't specify, but I'm assuming that the approval ratings are in percent. So that means that this number is like 29.28%, just so that you don't put in the 0.70 as the percent. So anyway, here it is, 1.023 times 70 minus 29.285. So we expect that there's nearest integer. So we expect his approval rating to go down to 42%. Clearly, this is a town that doesn't like their mayors very well, or they don't have a very good history of having mayors do well after, based on initial approval rating, and then they're not so happy at the end. Sounds like New York City. All right, looks like we may have just one more to go. And let's take a look. Fans of science fiction show Space Cruiser Zeta, I don't know why they didn't just call it Star Trek, are hosting a convention. To figure out how much space the event will require, so to speak, that's sort of a pun, the convention center looked at the space requirements from previous conventions. For each convention, the employee recorded the number of attendees X, so the X is the number of attendees, and the floor space in square meters, Y. So Y is the square meters, which does seem like it would be a positive. In other words, for each extra attendee, you need 1.4 meters, square meters of space, which kind of makes sense. A square meter is about a 3 by 3 foot area. Now, in today's world of 2020 and social distancing, this would actually change, wouldn't it? So anyway, something to think about. If they have 7,005 attendees, we're going to substitute the attendees in for X. And so we have 1.431 times the 7,005, they're going to make it specific, minus 1,383.065. I don't know where this came from, but anyway, there it is. All right, 1.431 times 7,005, and we're going to subtract the 1,383.065. And we're going to round it to the nearest integer. That's going to be 8641.09. So it looks like it's going to be 8,641 square meters. 8,641 square meters. Looks good. And yep, that was it. I hope you guys enjoyed it. I love interpreting these, as you can probably tell. So I'll see you back again. Bye.